Hello everyone. Today's video is about RAII. It's an abbreviation for Resource Acquisition is Initialization in C++. So let's begin. In C++, memory management and handling other resources like file handles or network connections can be quite challenging. If not done correctly, it can lead to resource leaks and some undefined behaviors. RAII is one of the core principles in C++ that helps manage resources safely and efficiently. It ensures that resources are properly acquired and released automatically without requiring manual management. So let's break down the concept step by step. The idea behind RAII is simple. Resources that a program acquires should be tied to the lifetime of an object. This means that when an object is created, it acquires resources, and when the object is destroyed, it automatically releases those resources. This works due to constructor and destructor behavior in C++. When an object is instantiated, its constructor runs and performs any necessary setup. Conversely, when the object goes out of scope or is explicitly deleted, the destructor is invoked, releasing any held resources for that object. RAII makes resource management deterministic because destructors are called automatically when an object's lifetime ends. This principle is not only about memory, but also deals with other resources like files, sockets, and locks. So, what is RAII is solving for us programmers? Before RAII, developers had to manually acquire and release resources, often leading to bugs. For example, if you open a file, let's do this. So this is how you can handle a file without RAII. It's just an example, it's not what you should be doing. A file pointer. Let's open a file that we already have, and with write privileges, and if not file, return and include iostream. Yeah, this is the common practice, and this is the pitfall that the developers were falling into. And here, if the function returns prematurely in that line, or some other line that you can type here, the file gets opened and it keeps open. It's not closed, so any other attempt to open this file will be failed. What you need to do is close this file with fclose somewhere else. So just no fclose is there. So how RAII works, this is how we mostly handle files right now. So let's have a class called file handler. It should have a file pointer that we open, and with the constructor we should be opening the file right at the moment that we are constructing with the correct mode. File name, mode, and if you cannot open, so that means you are getting a handle of the file when you are constructing the object, and also while you are destructing it, you need to handle that you need to be freeing the resource. So if file f close file, and let's say you have a method called write that will be handling any attempts to write to that file, f printf. Yeah, just like that. This is what you should be doing right now. So how do we use this class in our code? We should be doing and give write privileges. Yeah, you should be doing just that, and also catch. You see that? When you construct this object, it gets the handle for the resource. So at that moment, no one else can open this file and change it, etc. And after our try catch block ends, this will get distracted because it will be out of scope, and that's when we close the file. So anybody else that will try to open that file, they will be available too. This is the essence of RAII. The resource, in this case the file, is acquired when the object is created and is automatically released when the object is destroyed. You can also use RAII in memory management. It's also possible to, instead of allocating and deleting in different scopes, you can use also constructor and destructors to allocate and deallocate memory. The class will be similar to this one. Instead of file handler, you will have a memory handler. You should also include memory. But also, this is not the only way that you can handle memory. With using this library we have, you can also use std unique pointers. For example, this is a dynamically allocated array that will be deallocated when it is out of scope. Yeah, it is possible to use unique pointers. A unique pointer is a type of smart pointer that will allow only one owner of the pointer. So this is the manual allocation that you have done, but when the unique pointer is getting distracted, this will also get distracted and the memory will be freed. So what are the advantages of the RAII? Let's say RAII provides several important advantages. First is exception safety. RAII guarantees that resources are released even if exceptions are thrown, because the objects will be deleted no matter what. If you don't use RAII, you will be freeing the file in, let's say, that line, and when the exception will be catched, we will not be closing the file. So this gives us that opportunity, and it provides simplified resource management. You no longer need to remember to manually free resources, and also it gives the advantage of deterministic destruction. Resources are released as soon as object goes out of scope, ensuring timely cleanup. So what are the common uses of RAII in C++? Let's see. First is file handling, of course. The second one is memory management. And also you can use RAII on threads synchronization. How do we use it in thread synchronization? You will wrap your threads in classes like this file handler, and you need to join your thread on the destructor, so you will be sure that all threads are closed before your program ends. So RAII is a powerful concept in C++ that ensures safe and automatic resource management. By tying the acquisition and release of resources to the lifetime of an object, RAII provides a mechanism for cleaner, safer, and more maintainable code. You can apply RAII to various scenarios, such as memory management, file handling, and thread synchronization, making it a cornerstone of modern C++ development. Alright, I hope this resource comes in handy to you. Alright, see you in the next one. Bye.